Welcome to Chapter 6. We are going to start with Lesson 6.1 today, and you were supposed to have read through this lesson, so hopefully you have a good head start. We'll start off by saying taking a non-zero number to a negative power does not, this is really important right here, just because something's being taken to a negative power, that does not make the answer negative. It's going to be tempting to think that it should make it negative, but that is not what happens. I'll do a little thing here with you in a bit to show you. Another thing we want to keep in mind is that taking a non-zero number to the zero power does not, again, not make the answer zero. So we're used to that if we multiply by a negative, it may end up making it negative. Not the same thing when we're talking about negative powers. We're used to when we multiply by zero, we have a product of zero. Not the same thing when we're talking about a zero power. So I'm just going to go off to the side over here and I'm going to do a little something with you. I'm going to work kind of backwards here. If I have 2 to the third power, it means 2 times 2 times 2, and that is equal to 8. If I have 2 to the second power, that means 2 times 2, which is 4. If I have 2 to the first power, so notice my powers are going down by 1 integer value each time. 2 to the first power just means 2. So notice what's happening. I have this 8 here. When I decreased the power by 1 integer, really what I do is I divide by 2 and I'll get what the result of that one should be. If I divide by 2 again, so now let's see then what do you think is going to happen? Because if we follow that pattern, divide by 2, 2 divided by 2 is 1. So 2 to the zero power is going to be 1, not 0. And now I'm going to divide by 2 again. If I keep decreasing my powers, my exponent goes down by 1 integer. So now it's going to be 1 divided by 2, which is 1/2. And now, and I'll just do one more here, 2 to the negative 2 power. Got to divide by 2 again. So it's kind of like saying I'm taking a half and I'm dividing it in 2 parts. So a half divided into 2 is really 1/4. So notice we have negative powers going on now in these last two, but we don't have a negative result. We have actually what ends up happening is we get a number that is getting smaller. So when you take it to a negative power, the larger the absolute value of the negative power, the smaller it is going to be, but it will never, ever reach 0. It will never, ever reach and become a negative number. So here are some of the things we can count on when x does not equal 0. So if the number that we're taking to a power is not 0, we can count on that anything to the 0 power, whether it be a negative number or a positive number, anything to the 0 power will be 1. Another thing we can count on is if we're taking any number other than 0 to a negative power, when they tell us to simplify it or get rid of that negative power, and we got to do it without our calculator, then we can notice over in our examples when we were doing a negative power, I could take this 2 right here and write it as 2 to the positive 1 power. 2 to the first power is 2. I could rename this 4 here as 2 to the second power, because 2 squared is 4. So what we can count on is that if we have a negative power, we can write it as the fraction 1 over that number to the positive n power. So the power that was negative upstairs comes downstairs, our base and the power, and it becomes positive. That's how we eliminate the negative power. Well, the same goes for if I have 1 over x to the negative n power. If it's negative downstairs, it can move upstairs and become positive. So this is how we're going to deal with zero powers and negative powers when we're working with our exponents. Okay, very important, and this is critical. You have to have an understanding of this. If I have negative or the opposite of, so here's my negative sign. If I have negative or the opposite of 2 to the 4th power, that does not mean the same thing as negative 2 in parentheses to the 4th power. The first one are negative, without the parentheses, 2 to the 4th power. Only the 2 is being taken to the 4th power. So notice what? That negative sign is kind of like its own multiplier. And then 2 to the 4th power is 2 times 2 times 2 times 2. So if I have those 4 positive 2's being multiplied, that becomes 16. And then I have to go back and say, oh, there was that negative at the beginning I have to multiply by. So this is equal to a negative 16. Whereas the other one, this one right here, that means, because it's in parentheses, that negative 2, it is saying that negative 2 is being taken to the 4th power. So negative 2 times negative 2 times negative 2 times negative 2. Well, we have a negative times a negative, positive, times another negative, now it's negative, times another negative, now it's positive again, and 2 times 2 times 2 times 2 is 16. So notice we get a different result. We get positive 16. So I want you to evaluate the one that I have written here. Negative, in parentheses, negative 2 to the 3rd power. What does that really mean? Don't use your calculators. So go ahead and do it. And then I will do it in a bit. You don't want you copying me. So go ahead and do it. I'll give you a little bit of time. Okay, hoping that you're done. The negative sign that's out front is its own multiplier of a negative, which you can think of it as a negative 1 if you want to. The negative 2 in parentheses to the 3rd power means I have 3 factors of negative 2. So for the moment, I'm just not going to mess with this multiplier of negative out front, this really negative 1. And I'm going to go with what's negative 2 times negative 2. Well, you know what, maybe first of all I should just say that's 4. And then I still have this other negative 2 left at the end there. So this right here. So now I still have my negative 1. I'm just going to let that hang out up front there as a multiplier. And I have 4 times negative 2, which is negative 8. And now, last but not least, negative 1 times negative 8, we end up with a positive 8 as our result. So when I have to simplify that, evaluate that, I should end up with a positive 8. Now, sometimes you actually get away with, you might not do it the same way I did here, and you might do, but I got the same answer, Mrs. LeGrand, so apparently I know what I'm doing. Yeah, sometimes you're going to get away with it. There's going to be other times you're not going to be able, you're not going to get away with it. You're not going to get the same result, and you're going to be like, how come? Okay, let's go to the back side. So note at the top, this is really important, so if you want to put a box around it, that might be a really good idea, because you don't get to claim that an expression is simplified if it still has negative or 0 exponents in it. So until you have rid it of all of those, it is really not truly simplified. Just like you tried to tell me possibly that you've started with 36 over 64, and maybe you eventually get it down to, or not 36 over 64, excuse me, 36 over 6 72, and you get it down to, let's say, 3/6. You say, I'm done. I'm like, no, guess what? You still can simplify that. 3/6 can still be simplified to 1/2, not done yet. So we're going to be doing the same thing. We're simplifying now. And when we simplify these powers, we cannot have negative exponents left in them. We cannot have 0 exponents left in them. So 10 to the negative 4 power, we're going to use that rule on the front that said this is really x to the negative n power. So the rule up front says we can rewrite x to the negative n power as 1 over x to the positive n power. Remember that in the front I said? So we're going to write this as 1 over 10 to the positive 4 power. That's a mess. Let me try that again. 1 over 10 to the positive 4 power. Well, now we're just going to take that a step further, though, because we know what 10 to the 4th power is. 10 times 10, 100. 100 times 10, 1,000. 1,000 times 10, 10,000. So we have 1 over 10,000 as our final answer. Now, I do not want you using a calculator for these. I do not want this answer. Not. This is what your calculator might possibly give you. And that's how I'll know you're using your calculator rather than processing it through using the rule. So this is how we're going to give it. Okay, so now let's try our negative 2 to the negative 4 power again. Same thing. We really have x to the negative n power. Our x is negative 2, and our n is negative, or is 4, so we're going to we'll be able to apply our rule to this one also. So we have 1 over, that negative 2 must stay in parentheses, and the 4 is going to be positive now. So we have the n without the negative sign in front of it. Again, we can actually multiply this out now. We have our 1 upstairs is going to stay 1. And now we already did this negative 2 to the 4th power on the front side. Negative 2 in parentheses to the 4th power, if you remember right, became a positive 16. So 1 over negative 2 to the 4th power is 1/16. Okay. Let's try the next one. Let's go straight to doing it here without saying x to the negative n power. We're going to put a 1 upstairs because we see that we have a negative 2 being taken to the negative 5 power. So we have our negative 2, and that negative 5 is now going to become a positive 5. And now, well, you know what, if negative 2 to the 4th power was 16, we just have one more factor of negative 2 now. So what's 16 times negative 2? So we should end up with 1 over a negative 32. And if you remember right, when we have a fraction that's got some negative signs involved in it, if we have 2 negatives, a numerator and a denominator that are negative, we're going to have a positive fraction. If either the numerator or the denominator, just one of them is negative, remember we can bring that out front and say we have a negative fraction. Okay, let's see what happens when those parentheses aren't there. You know, like I said, sometimes we might get away with certain things and be like, I still got the same answer, but let's do it the way we, should, following the rule. That negative sign is not attached to the 2 because it's not with it in parentheses. So what we really have here is a negative, and let's just call it a negative 1. Remember this right here, I'm calling that a negative 1. Times, now we're going to rewrite this part, the 2 to the negative 5 power, as 1 over 2 to the positive 5 power. And let's just keep going here. We have negative 1. Well, 1 over 2 to the positive 5 power. So now we're taking 2 to the 5th power. No negatives involved here right now. 2 to the 5th power is 32. So we have 1 over 32. And basically now we're saying, okay, you got to take negative 1 times that fraction 1 over 32. It's going to create a negative fraction, negative 1 over 32. So hopefully you will start discovering when is it important that those parentheses seem to matter, and sometimes they don't really seem to matter. I'm hoping that as you keep working with these, you will make some sort of a discovery on your own. Okay, moving on to, we're actually on page 393 to check it out. And what we're doing here is we are to evaluate, okay? So we're going to substitute in, and we're going to evaluate p to the negative 3 power for p equals 4, okay? So there's a couple of ways we could go about it. We could first substitute and then simplify, or we could simplify this first and then substitute. Let's go with the substituting first. So 4 is going to go in place of the p. So we have 4 to the negative 3 power. 4 to the negative 3 power can be simplified, get rid of the negative power, as 1 over 4 to the 3rd power. And now, again, try not to use your calculators. 1 over 4 to the 3rd power. Well, 4 times 4 is, okay, 16. And 16 times 4 is, yes, 64. 1/64. Okay, let's try 3b here. Again, let's go with the substitute first method, okay? So 8, and then we're going to insert the time sign that's invisibly in there right now. We have negative 2. When we substitute, we must use those parentheses to the negative 2 power. So 8 to the negative 2 power is going to become negative 2 to the negative 2 power, because a is supposed to be negative 2. And then times b to the 0 power. B is 6, kind of looks like a B when you write it, and we have to the 0 power. Okay, so 8, you know what, no reason to rename that. It's not being taken to a negative power, it's not being taken to the 0 power. 8 is 8. We're going to leave it 8. The negative 2 being raised to the negative 2 power, we need to get rid of that negative power. So 1 over negative 2 to the positive 2 power. And remember, anything that is not 0 being raised to the 0 power is 1. So let's keep going here. Now that I see I have a fraction involved in the middle there, I'm going to make all these other integers into fractions. 8 can be put over 1. 1 over negative 2 squared. Negative 2 times negative 2 is positive 4. And then my 1 can be made into a fraction also by putting it over 1. So now I should be able to just multiply across. 8 times 1 times 1, 8. 1 times 4 times 1, 4. Guess we're still not done. 8 over 4 is 2. Our final answer for this one is 2. Okay, now let's be challenged. Let's go with find the missing value. You're going to have some of this to do in your homework also. So it starts with 1 over 25 is equal or is the same as 5 to what power? That's really what it's asking. We have to figure out what power would you take 5 to that would result in being 1/25th. So I'm going to help you out here showing you that here's, like maybe a productive way to go about this one. Let's take this 1/25th and let's first rename it with that 25 being a power name, because hopefully you recognize that 25 is the same as 5 squared. So what I've really done here is I've taken this 1/25th and I've renamed it as that. So now, but we need that 5 Notice here, this 5 has to be upstairs, not downstairs. So remember that rule up in the front that said if you have 1 over x to the n power, we can work backwards and that can become x to the negative n power. So this 1 over 5 squared could be rewritten as 5 to the negative 2 power. We have just found our question mark. The question mark is negative 2. What power do we take 5 to? That is the same, it is equivalent to 1/25. Okay, the next one, our question mark is in a numerator over an 8, and we have, it's the same as 2 to the negative 3 power. So again, I want us just to, first of all, oh, you know what, in this one, probably the way to work this one is to take the, always take the one that you have, that you know, and give it a new name. So I think what we'll start with is we'll say 2 to the negative 3 power could be rewritten as 1 over 2 to the positive 3 power. Well, that could be 2 to the 3rd power, could be renamed as 8. It appears our question mark is right here. Here it is. We ended up with something over 8. So in this one, the question mark, that's a great question mark, the question mark, not getting any better, is 1. Okay, so notice what we did each time. So this first one, we took the 1/25 and we renamed it. Okay? The second one, we took the one that we knew, we renamed it. So in this next one, we have 2 times 3 to the negative 2 power. What we're going to do is we're going to, and then it's equal to 2 over question mark. Let's take this part, and let's say, oh, well, that can become 2 times 1 over, remember, 3 to the negative 2 power can be rewritten as a fraction 1 over 3 to the positive 2 power. So now that can become 2 times 1 over 9, because 1 over 3 squared is 9. Now, you know what? We can make our fraction, our integer 2 into a fraction by putting it over 1, so that we can multiply. 2 times 1 upstairs, 2. 1 times 9 downstairs, 9. And we were looking for, right here, 2 over something. Looks like we've got it, 2 over 9. So we're going to say the question mark is 9. So you're going to be challenged with some of those in your homework also. And don't just come up with answers without something to support it along the way, as we've done here. All of your homework requires the kind of work that we have been showing in our notes. So don't just come with answers for these problems that you've been assigned for homework that you're now going to start working on. Good luck.